Hello friends, welcome back. In this tutorial, we will study about depth first search algorithm. Depth first search is a graph traversing algorithm. In this algorithm, we process the vertices of a graph in depth first manner. Now see how we process the vertices of a graph in depth first search. Suppose we have started from a node S of graph. Then we will move to one of the adjacent unprocessed node of node S, right? And then from that unprocessed node, we will move to one of its adjacent unprocessed node. And from that node, we will move to one of its adjacent unprocessed node, right? And so on. Once we reach a node which doesn't have any adjacent unprocessed node, then we will process that node, right? And move back to the previous node which we have reached before this node, right? Now we will check if this node has any adjacent unprocessed node or not. If it has any adjacent unprocessed node, then we will move to it and same procedure is repeated. If it doesn't have any adjacent unprocessed node, then we will process it and move back to the previous node which we have reached before this node. Now suppose there is a graph G and we have to traverse it by depth first search algorithm. Then in depth first search, for each vertex V of graph G, 4 variables are maintained. First is color V, right? This variable stores the color of vertex V, right? Color of a vertex can be white, gray or black. White color shows that the vertex has not been discovered. Gray color shows that the vertex has been discovered and it is being processed, right? And black color, it shows that the vertex has been processed, right? Second variable is pi v, right? It stores the predecessor of vertex v, right? dv and fv are two timestamps, right? Actually they are integers, right? dv records the time when vertex v is first discovered. So dv is called discovery time of vertex v, right? And fv, it records the time when vertex v's processing was finished, right? So fv is called finishing time of vertex v, right? Initially, color of all vertices of graph G is set to white and predecessor of all vertices of graph G is set to nil, right? Now, there is an integer variable time, right? There is an integer variable time which is initialized to 0, right? Until all vertices of graph G becomes black. We will take any white vertex V of graph G and call depth first search visit function on vertex V, right? Now, what this depth first search visit function does on vertex V, right? The depth first search visit function on vertex V, what it does, right? Now, when depth first search visit function is called on vertex V of graph G, then first of all, color of vertex V is changed from white to gray, right? Then value of variable time is increased by 1 and then discovery time of vertex V is set equal to time, right? And for each adjacent vertex u of vertex v, which is white, vertex v is set as its predecessor, right? And then depth first search visit function is called on that vertex u, right? After that, color of vertex v is set to black. Value of variable time is increased by 1, and then value of variable time is set as finishing time of vertex v. Now, suppose this graph is given to us and we have to traverse it by depth first search algorithm, right? So, initially, the color of all vertices of this graph will be white, and the predecessor of all vertices of this graph will be nil, right? And value of variable time will be 0, right? So in depth first search traversing of this graph, right, here I have partitioned each node of this graph into two parts, right? First part will store the discovery time of the vertex, and second part will store the finishing time of the vertex. So suppose there is a node v, or we can say suppose there is a vertex v, then the first part will store the value of variable dv, right? So first part will store the value of discovery time, and second part will store the value of variable fv. So second part will store the value of finishing time of vertex v, right? So what we have to do, we have to take any white vertex of this graph, and we have to call depth first search visit function on that vertex. So here we have chosen this white vertex b, right? And we have called depth first search visit function on this vertex b, right? So what will happen, first of all, the color of this white vertex b will be changed to gray, right? Now the color of this white vertex b has been changed to gray. Then the value of time variable will be increased by 1, so it will become 1, right? And then we will set the discovery time for this vertex b as the value of variable time, right? So discovery time of this vertex b will be set to 1 because the value of time variable is 1, right? Now we will take any white adjacent vertex of this vertex b, right? Now vertex c and d, they both are adjacent to vertex b and their color is white, so we will take any one of them. So here we will take vertex d, right? Vertex d is adjacent to vertex b and its color is white. So what will we do? We will set vertex b as the predecessor of vertex d, right? Now vertex b has been set as the predecessor of vertex d, right? Now we will call depth first search visit function on vertex d, right? So when we call depth first search visit function on vertex d, what will happen? Color of this white vertex d will be changed to gray, right? It will become a gray vertex. Then we will increase the value of variable time by 1, right? Then the value of this variable time will become 2, right? Now this value of a variable time will be set as the discovery time of vertex D, right? So discovery time of vertex D has become 2, right? Now what will we do? Now the vertex D has two adjacent white vertices. We will choose any one of them. We will take any one of them. It has two adjacent white vertices, vertex C and vertex E, right? So we will take vertex E, right? We can take any one of them. Either we can take C or we can take E. So here I have taken this vertex E, right? So what will we do? We will set vertex D as the predecessor of vertex E, right? Then we will call depth first search visit function on this vertex E, right? When we call depth first search visit function on this vertex E, the color of this vertex E will be changed from white to gray, right? Then we will increase the value of variable time by 1. Now the value of variable time will become 3, right? Now this value of variable time will be set as the discovery time of vertex E. Now the discovery time of vertex E is 3, right? Now vertex E doesn't have any adjacent vertex, right? So there is no adjacent white vertex to vertex E on which we can call depth first search visit function, right? So what will we do? We will set the color of this vertex E black, right? We will change the color of this vertex E from gray to black, right? Now we will increase the value of variable time by 1, right? Now the value of variable time has become 4. Now this value of variable time will be set as the finishing time of vertex E, right? So the finishing time of vertex E has become 4, right? So finishing time of vertex E is 4, right? Now what will we do? We will take another white adjacent vertex of vertex D, right? So what we have done here we will backtrack to vertex D and we will check whether vertex D has any white adjacent vertex or not. Here vertex D has a white adjacent vertex, that is vertex C. So we will set vertex D as the predecessor of vertex C, right? Now vertex D is the predecessor of vertex C. After this we will call depth first search visit function on vertex C, right? So when we call depth first search visit function on vertex C, then what will happen? Color of this vertex C will be changed from white to gray, right? And the value of variable time is increased by 1. Then value of variable time will become 5, right? Now this value of variable time will be set as the discovery time of vertex C, right? Now the discovery time of vertex C is 5. Now we will check whether this vertex C has any adjacent white vertex or not. This vertex C does not have any adjacent white vertex on which we can call depth first search visit function. So what will we do? We will change the color of this vertex C from gray to black, right? Now we will increase the value of variable time by 1. Right? Now the value of variable time has become 6. Now this value of variable time will be set as the finishing time of vertex C, right? So the finishing time of vertex C is 6, right? Now what will we do? We will backtrack to the vertex D, right? And we will check whether vertex D has any white adjacent vertex or not. Now vertex D does not have any white adjacent vertex on which we can call depth first search visit function. So what will we do? We will change the color of vertex D from gray to black, right? And we will increase the value of variable time by 1, right? Now the value of variable time has become 7, right? Now this value of variable time will be set as the finishing time of vertex D. So the finishing time of vertex D is 7, right? Now we will backtrack to the vertex B, right? And check whether vertex B has any white adjacent vertex or not. Vertex B does not have any white adjacent vertex on which we can call depth first search visit function. So what will we do? We will change the color of vertex B from gray to black, right? And then we will increase the value of variable time by 1. Now the value of variable time has become 8, right? Now this value of variable time will be set as the finishing time of vertex B. So the finishing time of vertex B is 8, right? Now what will we do? We will take any white vertex of this graph and call depth first search visit function on that vertex, right? Actually what we have to do, until all vertices of this graph becomes black, we will take any white vertex and call depth first search visit function on that vertex, right? So what will we do? Here two white vertices are left, A and G. We will take any one of them and we will call depth first search visit function on that vertex, right? So here I will take vertex A and I will call depth first search visit function on this vertex A, right? So first of all, when we call depth first search visit function on this vertex A, right, color of this vertex A will be changed from white to gray, right? And then value of variable time will be increased by 1, right? Now the value of variable time has become 9, right? And this value of variable time will be set as the discovery time of vertex A. So the discovery time of vertex A is 9, right? Now we will check whether this vertex A has any adjacent white vertex or not. This vertex A has an adjacent white vertex, that is vertex G, right? So what will we do? We will set vertex A as the predecessor of vertex G, right? Vertex A will be set as the predecessor of vertex G. Then we will call depth first search visit function on vertex G, right? So what will happen then? First of all, color of this vertex G will be changed from white to gray, right? And the value of variable time will be increased by 1. So value of variable time has become 10. Now this value of variable time will be set as the discovery time of vertex G. Now the discovery time of vertex G is 10, right? Now we will check whether this vertex G has any adjacent white vertex or not. This vertex G does not have any adjacent white vertex on which we can call depth first search visit function. So what will we do? We will change the color of this vertex G from gray to black, right? And the value of variable time will be increased by 1. So value of variable time has become 11. Right. Now this value of variable time will be set as the finishing time of vertex G. Right. Now after this we will backtrack to vertex A. Right. Now we will check whether vertex A has any white adjacent vertex or not. Vertex A doesn't have any white adjacent vertex now, right? So what will we do? We will change the color of vertex A from gray to black, and we will increase the value of variable time by 1. So the value of variable time will become 12, and this value of variable time will be set as the finishing time of vertex A. So the finishing time of vertex A will be 12, right? Now see, all vertices of this graph have become black, right? So we will stop there, right? So in this way we can traverse a graph by depth first search algorithm.